When you receive a text message, reading it and typing a reply feels entirely intuitive. But for a machine to perform that same task, it has to translate our communication into computational logic. This process falls under the umbrella of natural language processing, or NLP. This covers the algorithms that allow computers to ingest, process, and output human language. NLP includes two primary components: NLU for reading comprehension and NLG for writing. Basic NLP handles the initial data ingestion, like breaking sentences into individual words. However, conversational AI requires NLU to grasp the context of those words, and NLG to draft a relevant response. Creating a system that interacts like a human requires solving two distinct problems. The machine must decode unstructured input before it can systematically engineer a coherent reply. The difficulty in that first step lies in the nature of human language. While computer code is mathematically precise, our speech is filled with nuances and words that change meaning based on their surroundings. Take this sentence: Alice is swimming against the current. To make sense of this, an NLU algorithm must determine exactly which version of the word current is being used. The algorithm uses syntactic analysis to map the parts of speech. It identifies current as a noun and links it back to the preceding verb, swimming. This relationship provides the context needed to define the word. Based on the proximity to swimming, the NLU engine identifies current as the flow of water. Now, consider this sentence: the current version of the file is in the cloud. Based on the words surrounding it, identify the part of speech and the word it modifies. In this case, current is an adjective describing the noun version. This change in the word's relationship to the sentence shifts the meaning to mean the most up-to-date status. Natural language understanding uses these syntactic relationships to determine the intended meaning of a sentence. By mapping how words interact, the engine can arrive at a logical conclusion about what a user is trying to say. Once the machine understands that intent, it has to write a response. This is the role of natural language generation, which uses machine learning models to build a reply. This process follows a three-stage pipeline. It begins with text planning, where the algorithm formulates the logical order of the information it needs to convey. In the sentence planning stage, the algorithm groups that data into paragraphs and adds punctuation to ensure the text flows naturally. The final phase is realization. This acts as a check against the rules of human grammar to ensure the output is technically correct. For example, during realization, the system identifies that the past tense of run is ran. It will catch an error like runned and correct it to follow proper grammatical rules. This three-stage scaffolding is what prevents an AI's response from becoming a series of incoherent data points, allowing the machine to generate text that reads naturally. We can see these systems working together in a standard customer service interaction, such as a user typing a complaint into a chat box. During the NLU phase, the algorithm parses the unstructured complaint, mapping relationships to determine the user's intent is a refund. In the NLG phase, the system moves that refund data through text planning, sentence planning, and realization, outputting a professionally drafted, correct response. These two systems perform different roles. NLU handles understanding through syntactic and semantic analysis, while NLG handles generation through its three-stage pipeline. NLU identifies what the user means, and NLG determines how the machine should reply. Together, they provide the framework for how modern AI communicates with the world.